So in this question it is given that a solid sphere of density rho and specific heat C of radius r at an initial temperature of 200 Kelvin is suspended inside a chamber whose walls are at almost 0 Kelvin. So here we can just consider that there is a solid sphere of density rho and its specific heat capacity, take it as C, and its radius is represented by r. The initial temperature of, and its temperature was something like 200 Kelvin, is suspended inside a chamber at 0 Kelvin. So that means its surrounding temperature is 0 Kelvin. It will not absorb any radiations. It will emit only thermal radiations. Because of that, its temperature is keep on decreasing, and after some time our aim is to find out what about the value of time required for the temperature of sphere to drop to 100 Kelvin. So we know that the equation for its rate of law of heat energy dq by dt due to thermal radiation, that is dq by dt, is equal to nothing but E sigma A temperature of object raised to 4. Now we know that if you removed q amount of heat energy, then the change in temperature of that object will be equal to ms delta T. So if we can write as dq is equal to mc, over here specific capacity is given as nothing but C, so we can take it as this is equal to nothing but mc dt, the value of dq. So we can take it as mc dt divided by dt. So over here this dt is representing basically temperature, so let's say it is represented by capital letter T, and this dt is nothing but time, is equal to E sigma A temperature of object raised to 4. So you can write the equation for it is, that is dt divided by T raised to 4 is equal to E sigma A divided by mc into dt. Over here all these things are basically constants. All these things are constant. So we can integrate this particular expression. So if you are integrating this particular expression from initial temperature, that was something like 200 Kelvin, and the final temperature is 100 Kelvin. So over here you can observe that with respect to time the value of temperature is decreasing, so the value of dt should be a negative value, so we can put a negative sign over here, and we can integrate on this side, and where the value of time is changing from 0 to t. So if you are integrating this particular expression, that is t raised to minus 4 plus 1, that is t raised to minus 3 divided by minus 3, and the limit of this one is changing from 200 to 100, is equal to E sigma A divided by mc into dt, the integration of dt from 0 to t. So we can put the limit, and we can cancel this negative sign. So the equation becomes 1 divided by t raised to 3, the limit is changing from 200 to 100, is equal to nothing but E sigma A divided by mc into t. So we can take it as nothing but 1 divided by 100 raised to 3. So we can take it as 1 divided by 100 raised to 3 into 1 by 1 minus 1 divided by 8 will be equal to E sigma A divided by mc into t. So we can take it as nothing but 10 raised to minus 6 into 7 divided by 8 E is equal to E sigma A divided by mc t. So we'll get the value of this t. The value of t will be equal to 10 raised to minus 6 into 7 divided by 8 into m into c divided by E sigma A. So we can write the equation for T is 10 raised to minus 6 into 7 divided by 8, and over here the mass of object is not given, so mass we can take it as mass is equal to density of object into volume of object into C divided by E sigma into E. So in this question it is given that the value of density of object we can take it as nothing but rho, and its volume, it's a spherical shape object, volume can be taken as 4 by 3 pi r cube into C divided by E into sigma into E. E is nothing but 4 pi r square. So we can cancel this 4, we can cancel the value of this pi and the value of r over here. So we can write this expression as 10 raised to minus 6 into 7 divided by 8 into rho into C divided by 3 E sigma. So we can find out the answer for it. So after calculating this, you will get the answer for it.